Welcome to the module on Introduction to Statistics. By the end of this module, you would have understood the basic concepts of statistics and how precisely to use them in research. Let us try and understand the background of statistics. The word statistics has been derived from the Latin word status or the Italian word statista or the German word statistik, each of which means a political state. Initially, statistics was concerned with the economic, political and demographic particulars of a country. However, today statistics has broadened to include many things. It is so important in our day-to-day living that many of us often use statistical analysis in making decisions without even realizing it. In recent years, the growth of statistics has made itself felt in almost every phase of human activity. Statistics no longer consist just merely the collection of data and their representation in the form of charts and tables. It is now considered to encompass the science of basing inferences on observed data and reaching to decisions in the faces of uncertainty. We are all exposed to statistics in our day-to-day life. For instance, as students, we are very much familiar with the notion of our class 10 percentages. While watching cricket matches, we are used to comparing players and teams on the basis of various aspects such as their run rates, wickets, etc. We also decide whether the rainfall received in our cities and villages is above or below the average based on the figures of the previous years. During elections, we see much discussion on the vote share of different party candidates. Now, let us actually understand what is statistics. Statistics is nothing but the science of organization and the conceptual understanding of a group of numbers. These group of numbers are usually referred to as data. It is the purpose of statistics to take all these numbers or data and present them in a more effective way, in a more comprehensible way. Role of a statistician is to articulate what was found in an experiment or the observational study, why this finding is important, and to whom and what the data from these may mean in the future. A statistical background, hence, is indispensable in order to understand the research reports. So, in simple words, statistics is nothing but a set of procedures and rules used for reducing large masses of data to manageable proportions and for allowing us to draw conclusions from these data. Let us understand the actual definition of statistics. The most popular, exhaustive and comprehensive definition of statistics in the pluralistic sense is given by Professor Horace Sechrist. His definition states that statistics may be defined as the aggregate of facts affected to a marked extent by multiplicity of causes, which can be numerically expressed, enumerated or estimated according to a reasonable standard of accuracy, which can be collected in a systematic manner for some predetermined purpose and could be placed in relation to each other. Why do we all feel that studying statistics is important? Being an informed information consumer, we all should be able to extract information from the charts and graphs. We must be able to follow numerical arguments. We should be able to know the basics of how data should be gathered, summarized and analyzed to draw statistical conclusions. We should also be understanding and making decisions. We should be able to decide if the existing information for doing so is adequate or not. We should be able to collect more information if it is not adequate in an appropriate way. We should also be able to summarize the available data effectively and analyze it. Further, we should also be able to draw conclusions, make decisions and assess the risk of incorrect decisions. Thus, statistics helps us evaluate the decisions that affect our day-to-day lives. What statistics can do? It makes the data more manageable, easy to understand. It allows us to draw conclusions objectively based on those data and also helps us prove certain things with quantitative evidences. Let us come to some important concepts in statistics. The first and the foremost is the population. The entire set of events, people or phenomena about whom the researcher wants to study or the researcher is interested in studying is termed as the population. For instance, the researcher may be interested in all the tribal societies of India. He also may be interested in studying the students in the international baccalaureate schools in India. So, we see a population may range from a relatively small set of events, people or phenomena that can be enumerated very easily to a very large set that cannot be traced without a significant amount of time, money and manpower. The second important concept in statistics is about the parameters. When we are able to describe key aspects of the population, we are generating nothing but the population parameters. Some of the population parameters, for example, on the Census of India website include literacy, male to female ratio, number of employed and unemployed persons, etc. The third most important concept is the sample. Most research cannot attempt to undertake census-like operations. So, majority of the research is undertaken on smaller sets that are drawn systematically from the population. We call this smaller set of events, people or phenomena as a sample. For example, if you want to check whether there is sugar already in the cup of tea that is served to you in a restaurant, you would usually sip a little tea to make sure before adding any more sugar. The little which you taste is essentially a sample representing the larger teacup. In this case, the teacup contains the population in which you are interested. There is another concept in statistics which is termed as statistics and parameters. Here, let us learn a different meaning of the term statistics. In this context, statistics refers to a set of numerical values that the researcher will compute to describe the sample, such as the average value or the range of values, etc. For every population parameter, there is a corresponding sample statistic. A sample mean, usually written as x with a bar on top of it and is read as x bar, corresponds to the population parameter mu as in the Greek letter. Sample statistics are usually written in Roman scripts, while population parameters are written in Greek letters. The most crucial aspect of applying statistics consists of analyzing the data to obtain a more efficient and a comprehensive summary of the overall results. To achieve these goals, statistics is divided into two major areas, the descriptive statistics and the inferential statistics. Let us understand something more about descriptive statistics. The main purpose of descriptive statistics is to describe the data. It comprises of several tools such as tables, graphs and basic descriptions of numbers such as the averages or the means. These tools help in collecting, classifying and summarizing the information about the actual observations. The most well-known descriptive statistics are the mean, which is the statistical average, and the mode, which is nothing but the most frequently occurring value in your data. Let us see what is inferential statistics. Inferential statistics is primarily comprised of several tools which are used for generalizing beyond the actual observations. It involves making informed and calculated inferences about a large group of data, which we call as the population, from a smaller group of data referred to as the sample. Typically, sample data is randomly drawn from the population or the larger group of data. The concept of random sampling means that every unit or person in the population has an equal chance of being included in the limited size sample. Let us know more about the types of data. The precise form of statistical analysis often depends on whether the data are numbers or words. Accordingly, there are two types of data: quantitative data and qualitative data. In quantitative data, any single observation which is in the form of a number which represents an amount or a count can be included. For example, height of a person, weight, time, temperature, volume, etc. On the other hand, if we talk about qualitative data, it is nothing but a single observation which is in the form of a word or a code that represents a class or a category. For example, if a survey records the response of students to the question, "Do you drink?" with the code Y for yes and N for no, then the resulting data would be qualitative. Often, numbers are assigned to the yes and the no replies to permit computer processing. But remember, we cannot derive a statistical average of these numbers. We can only report the most frequent value or the relative percentage of values. Let us understand the difference between qualitative and quantitative data as a comparison. Quantitative data involves measurement, while qualitative data describes the nature of something. In quantitative data, the data is in the numerical form, whereas in qualitative data, it is in the form of either words or codes. Quantitative data usually gives answers to how much questions, while qualitative data answers the what or of what kind of questions. The objectives and results obtained from a quantitative data analysis are usually unambiguous and conclusive, whereas in qualitative analysis, the results are often evaluative and ambiguous. Let us now go to the types of variables. Before that, let us understand what is a variable. A variable is a characteristic or a property that can take on different values. Depending on the different values of a variable, we can divide them broadly into four types: independent variable, dependent variable, predictor variable and criterion variable. Independent variable is a variable that can be manipulated by the investigator during an experiment. Its variation does not depend on any other variable, hence termed as independent. Dependent variable, on the other hand, is a variable that is counted or recorded by the investigator during his experiment. Predictor variable is a variable that is used to make prediction, while criterion variable is a variable that is to be predicted. Let us see the major characteristics of statistics. Statistics are aggregate of facts. These are affected to a marked extent by multiplicity of causes. These can be expressed numerically. These can be enumerated or estimated according to a reasonable standards of accuracy. Statistics are nothing but information collected in a systematic manner for a predetermined purpose. We must be able to place these statistics in relation to each other. Let us come to the functions of statistics. The first and the most important function of statistics is its preciseness and definiteness. Statistical techniques enable us to present the facts in a clear, precise and definite form. The second major function of statistics is the condensation. With the help of statistical tools, a huge mass of data can be condensed into a few presentable, understandable and significant figures. The third is the comparison. One of the important functions of statistics is the comparison. The absolute figures themselves do not convey any significant meaning. It is their comparison that helps us draw the conclusions. Statistical devices like the averages, ratios, percentages and graphs are effective tools that can be employed for the purpose of comparison. Formulation and testing of hypotheses also forms an important function of statistics. The statistical methods are extremely useful in formulating and testing hypotheses for the purpose of establishing a concrete relationship between two or more variables. For example, the degree of association between demand and price or between amount of rainfall and the yield of crop or between advertising expenditure and sales can be very well obtained using the statistical tools. Similarly, the hypothesis like whether or not advertising campaign is effective in sales increase can be tested by using the appropriate statistical tools. The next function of statistics is the predictive function. Statistical techniques can be used to analyze the past data and predict the future trends very easily. For example, the demand for a particular product for the next year can be very well predicted by knowing the demand for that product in the past and the current market trends and the possible changes in the factors that affect the demand. And finally, the last main function of statistics is the formulation of a suitable policy. Statistics greatly helps in the formulation of various economic, business and other policies of state, national or global level. For example, the government policies on education, taxation, pollution, law and order, social welfare, etc. are formulated on the basis of statistical data and the inferences drawn from their analysis. Similarly, business organizations also use a lot of statistics to design their policies in the areas of finance, marketing and personnel. Let us now see the uses of statistics. Historically, the use of statistics can be traced back to the ancient Egyptians and Chinese who used statistics for keeping state records. Today, however, the subject of statistics is one of the most powerful tools in any scientific inquiry. Statistics has found applications in a very large number of disciplines such as agriculture, industry, psychology, sociology, economics, insurance, business, biology, planning, management, etc. However, we also need to understand the limitations of using statistics. The field of statistics, though widely used in almost every sphere of life, does have some limitations. The first and the foremost is that statistics does not deal with individual figures. It only deals with aggregate of facts or figures. Single or isolated figures cannot be called as statistics. Statistics does not study qualitative data. It is the study of only those facts that are capable of being stated in the form of numbers or quantities. Qualitative phenomena such as honesty, intelligence, beauty, poverty, etc. cannot be studied directly using statistics unless these attributes are expressed in terms of numbers. Statistical laws are not exact. Unlike the laws of natural science, the laws of statistics are not exact. Thus, the conclusions based on them are true only on an average level. Another limitation of statistics is that statistics usually can be misused. The results can be manipulated or interpreted according to one's own interest. One of the major limitations of statistics is also that statistical interpretations requires a great degree of skill and understanding in order to get meaningful results. Only people having adequate knowledge of statistical methods can hence properly handle statistical data. What is the role of computers in statistics? Computing statistics often takes time and may involve human error during the calculations. Today, computers remove much of this pain suffered by the earlier statisticians. Using statistical programs, students can derive statistical outputs in no time. Computer packages like SPSS, one can compute multiple statistics using just one command. However, drawing statistical inferences still remains one of the important skills of the statistician and not the computer. Let us summarize the entire module. Statistics is nothing but the science of organization and the conceptual understanding of groups of numbers called as the data. It consists of two main subdivisions, the descriptive and the inferential statistics, depending on whether the researcher wants to describe his data or infer about the population based on the sample respectively. It is important to distinguish between quantitative and qualitative data. Quantitative data are always in the form of numbers, amount or a count. If the observation is in the form of word or a code that represents a class or a category, the data is termed as qualitative. It is also helpful to distinguish between independent and dependent variables. The former are manipulated by the investigator, while the latter are the outcomes measured, counted or recorded by the investigator himself. Statistical devices like averages, ratios, percentages, graphs, etc. are the effective tools that can be employed for the purpose of comparison. Today, the subject of statistics is one of the most powerful tools in any scientific inquiry. It has found applications in a very large number of disciplines. Moreover, use of computers has greatly reduced the statistical computations. However, let us not forget, only people having adequate knowledge of the statistical devices can properly handle statistical data. Hope this module has served as an introduction to a very important branch of science, which is statistics. Thank you.